So we begin the class. This class we discuss the connection. So check the attendance. 34. Atenta is sick. Visa. Bible. So Wally. Right? Good. Elisa. Dennis. Boris. Blessing. Ori. Victor. Okay, so starting the connection. You can see these figures here. This is I-shape steel made from the factory. And the connection for the steel structure, there is a lot of connection because we want to connect the two parts together. So the connection is very important for us. Unlike the concrete structure, you can see the connection. There is no very complicated connection for the concrete structure. Because that's why. Because the connection part for the concrete, we use putting the concrete into the component and make it together and shape it by the models. But the steel structure you can see here. You see here this part, like this column. The trees, rows of the column trees. This is support. Each part is complicated by this type of steel. So the connection is outside part, not make directly from the factory. So the connection, the requirement for the connection, the first thing we need to talk is we should make it safe and reliable, strong, stiffness, and the behavior should activities. The construction should be very simple and convenient. Simple convenience. We hope the connection method we can as very simple, like we play toys. Normally, the white connection types include three types. The most widely used is winding connection, and rubber connection, both connection. Both connection and winding connection is most used widely. the rubber connection to use some specific conditions.
So which one is the best among the three?
It depends. For the normally we likely use the wiring connection. Directly use the material connection together.
But in terms of wording, isn't wording like, wouldn't it just try to make it like a solid thingy meaning? Okay.
Okay, I can show you some cases.
Great.
You can see it. You can see it. You can see here the connection part, like this part connection. We use both together and the wording together. Both together. Wording together. Normally, widely used is for depends your construction, your building. Normally, if you make a very small house or small factory, you just can use the welding, separate welding or both. But you use a very important buildings, you should use normally both welding together. Both. It depends you. The principle for that is that very simple. You can follow after the wording. After the wording, you can listen here. Any method you can use, but after the wording, the force, the connection part should be smaller than limited yielding force of the wording connection. Okay, you can see here. Design or value of the welding stones. For special for this type of the steel Q235, when thickness is smaller than this one, the welding stones should be smaller than this one. Filter welding stones should be controlled at this value. Clear? Will be controlled. And later I will teach you how to calculate to judge this equation. How to judge this equation. Okay. You can see this is a bolt connection for the bridge, and this is bolt materials. You can also see some joint connection. This is joint for the roof system. So the roof element, you can put different force, different parts connection together to support the roof system. And also you can see we're welding together a very big column, using two parts, in the middle, mounting together with the same strong, and make these two parts together. Normally, you can find for a very large building, very high and very large span buildings. some parts of the steel, like column, is very short. Make it from the factory, not of such a long height. We all is the all method is together, working together to make a very long, a very high size, very high size. This is bridge. You can see here. This is connection together by bolts, and you can see a plant. Inside of the plant, we also working this together. Make it a very rapid connection, very rapid connection. This is the unit of the work of the bolts. This is the unit of the bolts. Also see, you can see this is a connection of the steel structure. So from this figure, you can see how to. Can you before study this one, can you imagine the job of you is to work? Well, the mission of you is to do what? You know? Before the study. For example, we print. Okay. Now I make the mark in the PPT. I think we have no videos. For example, this is connection. In this class, it's two columns, right? With columns, and your connection is together. How can you connect this? Oh. Not all. Can you plot it? How you connect it? The two parts. This is part A. This is part B.
I will draw it.
Great.
Which connection?
The A and the B. Connect it. The first step is the plant, right? And if the structure building is not very big, it's very small, not very big, you can directly use this method to work in this part. So it's okay, right?
Yeah.
It's okay. And so, how to check the okay? So I have a question.
How to check it's okay?
Right? Yes. How to check it okay? So sorry that if you use this one, there is no PPT because I think a video I cannot record this.
Even this one.
Even this one.
So, for me to report on the screen, how do you there now?
So even this one.
Yeah.
So I plot in here.
Use the answer.
Okay. Use it here.
The other, that one, that. It is.
What the question?
What?
You can withdraw on the board. You use this
Use this one. I draw it.
one. Yeah, you can draw, like it shows on the video.
Okay.
Yeah.
Okay.
Interest program.
Okay. Very good. I don't know.
But it is. Not appendix. Not appendix.
So these two parts.
Just yesterday.
It's a computer.
this is A and this is B. So we come back. If we're working together, how can you check it? It's a safety. It is safety. Tell me, how can you check it? If, for example, if there is a force applying here, how can you check the safety? Okay, now come back. For example, a column, this is a column, apply a force, apply here. So for this one, how can you check the force safety? You know how can know that?
Yeah, but how to explain it?
I mean here sigma
Yeah, like
smaller than or
no, that's
y for this, right? For this. So for this case, how can we check the safety? Because this is separated two parts, almost three parts. First part is here and here and here. A,
cut
B,
them.
C. So for this one, calculate the sigma is very simple. F over the cross section A, right? For this one, we should calculate the force separated from here to here, right? Now we zoom this part. This structure firstly loses the strength. First, become to future. How to spell? Failure. Become to failure. That means that connection will be lose the strength, right? So we should calculate this one. To calculate this one, apply the force sigma smaller than the material basic behavior sigma. Okay? That means so we plot the wording shape is like this. Right?
Good.
This is first complement. This is skill A, skill B. Working together. This is for example one. So the force is here and the cross section error is here. Right? So we can get the sigma and to compare the working strength of the material. Clear? This is basic logic to check the strength of the connection. Clear? This is for winding connection. Also, now we change another part. If we use a boat to connection together, so how to calculate the strength? Before later you will be studying the equation. But before that study equation, I want to figure out your logic. Right? If the boat, how to check the safety? Safety. How to check is it safe or not safe? how it is check how it is failure or not a failure. How use which method you will be used.
Attention.
The same method, you can see that the first which one loses strength will be affect all the structures. Which one? I assume both, right?
Yes.
Good.
Both. So how to check the both? We can find the force transfer to here, right? And the force F will be separate for each part for 6 bolts, right? So the F over the number of the bolts, right? For each force, each bolt comparing the force. Then the check use the same this equation to check the bolt material behavior and the bolt real burning the force in the bolt and the bolt basic behavior. Right? To check it is 60. If it is when if it is 60, we can think about it is 50. It will not check. So this is basic logic for you to build in your mind. Okay? So we come back to see activity. You can. Okay. So we beginning the first part we started the wording method. We classified the arc wording, gas wording, electric resistance wording, the basic wording method for you. Now we normally use. And the principle for wording is use the heart produced by the actors and the wording steel at the joint is mounted, and the mountain wording load is mixed to form the real joint after cooling. During the wording process, the wording life will directly contact with the air. So during in the air, the oxygen, some element will be make the wording life to affect the strength. Make the wording. So manually aqua wordings, the principle, the further is suitable for various wording positions and also wording order. Now from here you should be know that normally with the Q235 steel, this is steel pyramid, this is steel behaviors, and the E43 is wording load. This way normally we combine together. When you choose the Q235, you choose the E43 to be mounted. And when you choose the steering strength is 345 steel. Then we use the E50 wording. This picture is the wording stage, which uses the ARCO method. ARCO wording method.
What's the difference between soldering and welding?
You mean still different what?
The difference between soldering and welding.
Soldering.
I think it's the same as study. It's going to be bigger team, big projects. What do you use the word?
Sorry, I don't understand the soldering.
That thingy they say, let's say in a phone, let's say in a phone they want to connect the cable,
The wire.
the wire something like inside the phone. That small machine they use to melt. Okay. I told you that's it. But think about it, I think it's the same. It's the same, that's why it's so small. It's really small.
Another material as well.
Yeah, what they use the word about. Okay, I don't know. They do that. There's that one for melt. And that one for melt. They don't do that. Just that one. They're just using like a fire. Firing, that's what. Look at what the car road.
Oh, soldering.
Sorry.
Soldering. Normally it's smaller size parts, right? But welding is usually use special materials. Can explain by this one because the welding normally certainly normally used for the computer the small size materials. Welding is because we will choose another materials for burning this, for melting this. In here, this the Q43 is the material used in here, the bonds together. Okay,
So wait, let's say there are welding two steel materials, right?
yes.
The soldering rod, is it also steel or it's another?
And soldering is also another.
I mean, okay, sorry, not soldering.
Also, one more connection with the plastic thing.
Even the welding rod is different, it's not steel.
But with this welding, normally in the steel. Sorry, I'm not very clear about soldering.
Oh, okay, no, this is not about soldering, it's about welding. Let's say welding, since we use the welding rod, right?
Yes.
Yeah, is the welding rod also steel?
What material?
Normally it's steel. Normally it's steel.
So you use steel to put steel together?
Yes, the mention of this wording just to make the two steel connection.
Well,
I can't get why you smell.
That's a good joke, that one.
So you can see here, continuous. There is some other automatic submerged atom welding. This is big machine. This big machine to directly welding into the steel together. The filter is high speed. It is high efficient and large melting, deep, good quality, good plasticity, and small welding deformation, smaller heating effect, low range, suitable for long weld. You can see here the two welding guides in here, and directly to welding these two currents. For this welding together, they make the H shape steel by three parts. I zoom it. For here, you welding together, and then another side welding together, and also the bottom side welding together. and also this side welding together. Okay, now it will make a very big I-shaped steel. This steel can be made as a columns. Okay.
So let's say making skyscrapers. What is
Yes.
what is usually used? Welding or bolts? Or what is used to put the steels together?
You mean where we use the both?
Bolts?
For
No, I mean for really tall
yes,
skyscrapers.
I know that. I know that.
Yeah. What is used to put the steels together? Do we use welding or we use bolts?
Now this is make the current. This is the current. And then take the current together. During the construction, there is no complement when the worker to work together by hand. By hand, the workers, engineers in their own, in the structure like this to weld each part together. Like this, inside to weld together. They also have a lot of welding methods. We will not very speak. I will not give speak very speak too much about the other method. One is the gas straight welding method. Another is the electric resistance welding method. Gas shredded welding method is the same principle with the arc welding method. And the speed is fast. The wind speed will be not be because the wind speed should not be too large. For the electric resistance welding, the principle is use the heart generate by the current passing through the resistance of the connection. The weld depth can be smaller than 12 millimeters. Now we can see the welding connection form. Welding connection form. Normally the fault connection includes the bolt connection, left connection, and T-shape connection, and angle connection. The first page is this figure. We directly welding this in the middle to get connection together. And also we can use a plant to connection together, as I plot for you. And then the left connection means we connect these two plants directly. Don't use the plant to connection together. Just welding this round overlapped. And the T-shape connection, angle connection, we just connect in here, in here, in here. So the force, how to transfer in we deal when you deal how the force.
So it's too far. And the far away it's too narrow.
According to the relative position between the electrode and the weld, it can be divided the drawn weld welding, vertical welding, transverse welding, the overhand overhand. The downward welding is the best position. Is the best position that can produce weld with the best quality. Overhand welding is the worst welding position. You know that's why? Because in the top, the downward welding is like this one, and when the welding process, the material will fix all the zone, but the overhand welding, someone will amputate in here, lose some pump, air pump. So
logic. The connectors, right? Let's say the same. Let's say the boards we're using to connect the two steels. In terms of strength, looking at the two bars you're connecting and the same boards you're using to connect, are the strength like the same?
Sorry.
I mean, two steel bars. This one and this on strength level, even this one and this one strength level, right? And then what you're using to connect. Even if like does it have to be in the same let's say the same length, the same numbers, the same everything as the other materials?
And so what's your question?
Understand? Oh look, there are two steel bars.
Yeah.
This one
Yes.
and then you want to combine them. What are we used to combine? It have to be like the exact, like the numbers have to be exact, everything has to be the same with the ones you're connecting.
You means your two plans
Yeah.
want to connect together.
Yeah, like what you're using to connect. It doesn't have to have like the same.
You can use the wording and you use the both.
So
So
same wording and the both. The
Yes.
strength is more than.
you still want to focus the strength of the which one is bigger.
Yeah. So now my question is, does it have to be the same or the connectors have to be big, have to have more strength, right? That's yeah.
So you mean if you use the wording or use the both the strength which one is bigger? Is that one? Is this question?
I'll answer it that one. So.
So, are we going to do experiment on this? Welding.
Sorry, you can speak louder.
Are we going to do experiments on welding?
Yes?
Are we going to do an experiment on welding?
Do the experiments of the wording.
Yes.
Okay. For example, when in here you can see a lot of wording. Oh, sorry. Here. In here you can see a lot of wording part. Complement, right? One way we check the wording strength means we finish this wording as a tested samples, and we do the compression, the tension to get the strength. Okay.
No, his question is, are we going to do the experiment? Are we going to weld ourselves?
No,
You're practical. Are we going to practice? Are we going to practice welding?
practice.
No, like an experiment. Experiment. A welding experiment. Do we have a welding experiment?
Yes. So I explained to the how to do the experiment of the strength.
I think we might.
To that. So for this one, you want to use the laboratory to test the strength, right?
Again, this.
That means in here you can according to these figures, you can put in these figures. You wording this, and the size maybe can be different. But we test the extension that we're getting the strength from the test from the laboratory. Okay, you can see here. can see here, for the field wide, the strength we can get the strength is different from the same types of the test. Same type. We normally make a steel complement I shape, different shape, or tube steel, make from the factory. Then after when it will be concentrated in the site, we will do a test to check the strength. Now, we will use different welding methods to get the values, and the data will be used to make a table. Then we use the data to determine the strength. Okay. This is to test the experiment to welding. So welding have some welding mark. The welding mark function is indication the welding form, size, and the specific requirement. We can see that. The back hand for the welding is like this shape. The I-shape welding, the V-shape, single side V-shape welding, and the V-shape welding with blended edge, and also the U-shape welding. The felted welding, normally used this one, is the point weld. Different weld we will use different types symbols, and then we can plot in the figure to ask the worker to print it. You can see the butt wide for the two parts, and the belt wide for the two parts. The butt wide further with no stress concentration. No stress concentration, and the direct force transmission from the butt wide. And the classification as straight seam, the force is perpendicular to the seam, and the oblique seam, not perpendicular. With a different weld method from the part. For the stress structural requirements, the gross form depends on the plant, the thickness, and the construction conditions. The plant thickness is normally smaller than 10 millimeters, actually. 10 millimeters to 20 millimeters V and U shape, V and V shape, and bigger than 20 millimeters. For the thickness of the plant, we normally use the U shape, V shape, and S shape. The construction conditions, in order to ensure the quality of the construction, when one side of the work is finished, it is often necessary to turn over and remove the rods to rubber side for the returning work. If unconditionally, temperature backing plant should be filled at the roots of the work when the form is working correctly. Okay. I think everyone is